We usually view a rose through a lens of fragile aesthetics. We see its life cycle as a delicate balance of rich soil, consistent watering, and the right amount of sunlight. But this romanticized perspective adds layers of complexity that mask the raw biological engine at work. When we strip away the aesthetics, the botanical fragility disappears. We're left with a life cycle beholden to a single, repetitive environmental drumbeat. The entirety of a rose's existence, from birth to decay, can be mapped to one repeating variable: heat. To see the true life cycle, we have to look past the illusion of the flower and observe the relentless impact of thermal energy. In the dead of winter, a rose seed or a winterized bush sits in a state of absolute biological suspension. It is locked in the deep cold. This state only changes when environmental warmth begins to act as a physical catalyst. The rising temperature creates the first breach in the protective seed casing. Inside the seed, this thermal shift triggers a specific internal mechanism. As the soil temperature hits specific thresholds, enzymes begin to convert stored starches into usable energy. This newly available energy drives a sudden burst of cellular movement. The sprout breaches the surface of the earth, pushing through soil with significant force. This first phase of life is a forceful biochemical reaction triggered by the first heat wave. As ambient temperatures continue to rise, the plant moves into a phase of rapid expansion. The focus shifts from the initial sprout to the lengthening of the stem and the widening of the leaves. The second and third waves of heat act as a biological accelerator. The thermal drumbeat dictates exactly how fast the plant must grow. Botanists measure this using a metric called growing degree days, or GDD. As heat accumulates on the x-axis, stem height on the y-axis moves in lockstep. Cooler days halt structural progress, while hotter days force rapid cellular elongation. This expansion continues until the flower bud swells to its absolute physical limits. The rose's vegetative growth is a direct mathematical consequence of accumulated thermal energy. The life cycle finally reaches its climax as the tight petals snap open into a full, exposed bloom. There is a biological paradox at play here. The exact thermal force that generated the bloom immediately begins to break it down. Sustained high temperatures increase the rate of transpiration, or water evaporation. As shown here, the moisture leaving the petals begins to outpace the root system's ability to draw water from the soil. This leads to structural collapse. As cellular walls fail under the final wave of heat, the petals rapidly wilt, turn a dry brown, and finally drop away. The death of the flower is the inevitable conclusion dictated by the thermal environment. When we step back and look at the entire timeline, from the frozen dirt to the withered petal, we see a single narrative. The distinct phases of the rose's life are actually sequential expressions of heat. The rose functions as an active biological thermometer, continuously measuring its environment. This relationship suggests that many complex biological processes are at the mercy of fundamental elemental forces. Ultimately, to see a blooming rose is to watch the temporary rising and falling manifestation of thermal energy.